Hi everybody, my name is Nathan Glover and this is my talk for the AWS Community Day, Deploying Models to the Masses. To start with, let's go through a bit of an introduction about who I am. I am a DevOps consultant for Mechanical Rock. Some of my kind of hobbies and pastimes have always sort of revolved around machine learning and data scientists. I started kind of helping out some people with working with Jupyter notebooks, data platforms, and I kind of just fell in love with the idea of doing kind of DevOps with data science, so MLOps. And most importantly, I just love building weird and fun things that kind of make people smile. So I'm going to take you through the story of some good, some bad, and some ugly. So I've had a couple projects go semi-viral, and I guess I want to walk you through some of the problems and solutions I came up with, because sharing is caring, and I spend a lot of money, and hopefully me spending a lot of money and telling you about it helps you not spend so much money. I tackle most of these projects as well from like an ops perspective, and I like to sort of tell the story from that perspective because I think other people in the ops space might be really good in ML ops, but they don't really understand maybe some of the patterns that they might need to learn to get into it. So to start with, let's talk about the first project that I worked on. It was called These Cats Do Not Exist. You might have heard of different spin-offs like This Cat Does Not Exist, a lot of different alternate websites. We set up, or me and my friend Steven set up a version of this called These Cats Do Not Exist. We leveraged NVIDIA Labs StyleGAN. And we started out sort of just as a learning exercise for SageMaker. And overall, we got about 50,000 visitors in the first week. We got really lucky with timing. When we released the sort of website, there weren't many other websites in the space, so we got a lot of traffic from that. And we didn't even do it very well, like the actual site wasn't that great. So I'll give you a bit of a timeline to start with. We launched the model for the StyleGAN, launched on February 11th, 2019. About 5 days later, I started to learn SageMaker a lot more. I wanted to learn and I needed something kind of practical to use it with. I saw StyleGAN, I thought it was really interesting. And my friend Steven, who is infinitely more qualified than me, said, yeah, that's cool, let's give it a shot. So we registered a domain first, because that's what you do. You always register domains that you're stuck with having to build it then. And then a day later, we basically got a proof of concept set up on my friend's computer. This becomes a really bad habit of ours, and you'll see it later on in my talk. But we launched the site with the data that we generated off my friend's computer. And then we eventually did get it running in SageMaker, but that was a bit later when we'd learned a little bit more. So we posted it and we woke up to a lot of craziness. Hacker News, Reddit, Twitter, Futurism, CNN, weirdly enough as well. We had posts all over these sites and we were just getting tons of traffic from it. So I guess a lot of people ask the question, how did you build it? We didn't train a model. People ask questions like, what batch size did you use? And I'm like, I don't know, baker's dozen. Because ultimately, we were really very much the beginners to this. We didn't really know what we were doing, and we just used a pre-trained model, spat up some results, and made those results available to the community, people who are interested. So this is literally what we had behind the scenes. It was just an S3 bucket with a bunch of different images of generated cats that we made on our local system, and then we served it out over CloudFront, and that's it. So I like to say HTML is the best data science language because it was able to achieve our proof of concept really, really simply for everybody, just from that line of code there. So behind the scenes, though, we were doing a little bit more than that. We just exported hundreds of thousands of images to S3 and served them over CloudFront. But we did use the pre-trained model, pre-trained Keras model, and we produced a small little Jupyter notebook and a blog post that went kind of viral as well. So the costs, ultimately it didn't cost that much at all. The domain was the most expensive part. There was some small residual costs after that. That was primarily just the S3 image hosting, CloudFront, and some SageMaker inference. Ultimately, it didn't cost us much, and since it's been running, it hasn't really costed us anything. It's sat in free tier pretty happily. So that was a success for us. So I'll give you a little bit more a little bit more stats because people love stats. Overall, we had about 1 million requests to images. Basically, each image on the panel, though, was a separate request, so it wasn't a very good indication of how many visitors we got. But we served about 20 gig worth of image caching through CloudFront, so it was really good we used CloudFront, or we would have paid a lot more on S3 image get costs. And basically, since then, we've been receiving a very constant stream of traffic, and it's still a website that people really enjoy. So some of the learnings that we got out of working on this project was, I guess, the more that we learned, the less that we knew. We realized we had no clue what we were doing. We were very much so renegades in the Wild West. So yeah, next we were spoiled by pre-trained models. So at some point you have to learn how to do the actual ML rather than just taking someone else's model and making it easy for the community to get images out of. Google ads are also very, very hard to qualify for, and I will talk about this later in the talk because it really comes into play about monetization, but we didn't make any money from this project, and we did try, but Google declined us. Deploying large models is also really hard, so this model in question wasn't huge, but it was big enough that to run inference against it, we couldn't just stick it into a container. We probably could have, but we couldn't just expose that endpoint for inference to the world without causing a lot of costs, which we'll go into in a little bit more detail in the next project we worked on. And CloudFront and S3 can be quite expensive, and this was the most expensive cost for us, those two, and it still is. However, for this project, not so much. So now let's talk about the main project that we worked on, and that's selfie-to-anime. So I legitimately didn't get good sleep for about 2 weeks while we worked on this project. It completely broke the bank. It tested the limits of a friendship between me and my friend Rico Betty, who worked on it with me, and we learned a lot about some of the hidden service limits on AWS. So there are 2 timelines to this project. There's phase 1. Originally, this talk was written for phase 1. So this was the building and the iterating through the first big spike of traffic and getting through it. So that was August 2019 to March 2020, where we basically built out a very quick proof of concept. We wrote really, really bad code and we struggled with costs. Then we had a big kind of dip in traffic, and then our second spike in traffic, and phase 2, which is also part of this talk, is where we started to have to really try to solve some of the problems that we created in phase 1. And that was acknowledging bad architecture decisions, making time to fix those problems, and coming up with a proper monetization strategy. So let's get started. Phase 1, building and iterating. So let's look at some hard stats before we get into. This is all phase 1, bear in mind. But in the peak of selfie-to-anime, we were receiving about 6.5 million requests to our site. We cached at 500 gig plus worth of requests in that first period, and we served 615,000 selfies were converted and emailed to people. We had no monetization strategy for this. As you can imagine, it costed quite a bit. Okay, but what is selfie-to-anime? Well, on the right there, you can actually see an output from selfie-to-anime. It's built on an open source project called UGATIT, which is unsupervised generative. Exactly. I can't even pronounce it because we still didn't put that much time into really understanding what the model was doing. We just took an open source project and tried to reapply it to this project. Now, basically, this attentional network and adaptive layer instance normalization and image-to-image translation, put bluntly, it's similar to a GAN, generative adversarial network, but with this concept of attention maps that kind of guide the model to a better result. So let's go through kind of how that looks at a very, very high level simply. So we have a GAN. We take 2 input images. So we take a selfie and an anime selfie, and we downsample those in an encoder and outputs a feature map. We also take a residual block, which is sort of a hint from the previous step to point it towards a generated image. And we upsample it back into a normal image, and we basically have the image that we want from the output. then the point of a GAN is you have a generator and a discriminator. So the generator's job is to create images that look like anime characters, and the discriminator's job is to determine if the image that is created is a anime character, to determine if it is an anime or not. So its job is to basically look at an image that's generated and say, I don't think that's real anime. In fact, I think that's a really bad representation of anime. So the idea is that the discriminator and the generator fight with one another and make each other better by coming up with more complex examples, in this case, converting selfies to animes. So now let's start talking about costs. Now, we very quickly started to cost us quite a bit of money. Now, obviously for big businesses, you might look at these costs and stuff because it's like, wow, $15 max a day, that's nothing. You know, why are you even bothering? Now for us, we looked at that as $15 a day for the foreseeable future and potentially more. So obviously from our perspective, we looked at this and said, this is just losing us money. It's not making us money at all. So one of these first issues that we had was the $20 a day mistake. And that's where we were basically displaying these images on the front page of the site. We weren't lazy loading them. So every single time somebody accessed the website, every single one of those images was fetched from CloudFront. And that costed a lot of money, obviously. So this was a really, really simple fix for us. And it's a fix that I think a lot of sites can really benefit from. Just lazy load your images because your wallet will thank you in the future. Let's talk about the initial architecture of Selfie to Anime. So it was running in a Docker container on my desktop, and it was also running in the world's worst Flask or Python Flask app. I also felt kind of uncomfortable because this first proof of concept, really early, we had people uploading images and they were landing on my hard drive on my computer. And it was also single-threaded, so it could only ever handle and process one image at a time, so obviously. But again, when I built this, I did not expect people to start using it. So when people did start using it, we had to upgrade the architecture pretty quickly. And we came up with this serverless diagram on the right. And this was effectively how we were running it. However, we were still performing all the inference on my local desktop because I didn't really have a solution for running this immensely large model in the cloud. So for perspective, the model is about 15 gigabytes, which is gigantic compared to normal models. We'll get into more details later on some of the services we try to run it on, but for this purpose of this demo, just understand that running it on the local desktop was the only way around it at the moment. We also started to notice a couple bugs. Occasionally we'd have images uploaded that would just crash the entire program out. The rest of the architecture worked really well, so all the SQS queuing, great, worked perfectly. But the core Python loop had a lot of bugs, and we weren't catching any of these bugs. We just had this big while true block that was taking an image, shrinking it down, running it through the GAN, and then emailing the image off. That's it. So we had no in-depth understanding of what was actually happening behind the curtains, which was a huge problem. Another problem that we had was it was all running on my desktop still, and eventually I decided I'm just going to spin up a bunch of notebooks and run the models in that notebook over and over again in multiple notebooks. Problem is, you had to have the notebook open in a tab. So I had a few cases where I was coming home from work or going to work and I had a notebook instance opened up on my phone just to process images. That's how many requests we had. I had no way of handling this problem. And in my downtime, all I was doing was bug fixing, and we were struggling to scale to meet our demands. Finally, I decided, no, enough's enough. I need to pay off this debt. So I basically sat down and spent the next couple nights just paying down technical debt. I added, try catches everywhere. I fixed logging. I just optimized as much as I could. I went back and I paid down the problems that I'd created myself. So in the end, we came up with this simple architecture 1.0, and this was the first time when the entire stack kind of worked by itself. It didn't need me to run anything in my browser or open anything on my phone. It scaled up more or less autonomously, so I was able to get a pretty good night's sleep. It wasn't necessarily the cheapest way to run it, but at least it let me get sleep. Then we ran into more problems around service limits. So in our case, we hit the SES send limit, And this is the send limit after the initial one that you get unlocked. So when you talk to support, you can only send up to something like 20,000 emails. We got past that, fine, and we hit 50,000. And but then we hit the 50,000 email limit in a day, and we were like, what? So we opened a support ticket, and luckily it got resolved fairly quickly. But in the meantime, we were getting messages on Facebook telling us, please, why can't my images be processed? I'm not getting my emails. So the positive is that people really wanted to use our service. The negative is that we'd hit the point where we were struggling to scale. Now, let's talk about monetization, because this is the elephant in the room for us. Basically, we applied for Google Ads, but we just kept getting declined. And the reason for that is because the approval process is pretty strict to stop people from abusing it. A lot of the time, we just get told you need to have more content on your website. And unfortunately, because our website is a single-page app, really all we're doing is allowing people to upload images. They weren't going to approve us. So what we did was we added basically a blog section to the site. We added some blogs that explained how the process of self-anime worked. But even then, we weren't getting approved. This was really kind of demoralizing because we weren't making money, and it was a very stressful time in my life. So we unfortunately went for one of the competitors of Google Ads called Propeller Ads. And we managed to make back quite a bit of the money that we'd kind of invested in the project around August, September. However, around that time, the traffic did also drop off. And the problem with Propeller Ads is that they're awful, but so was going broke. So for people who haven't used Propeller Ads before, they're a little bit dodgy because they kind of serve out those kinds of ads where they ask you to enable notifications on your mobile phone. It's not like sending you malware, but it's kind of directing you in the direction where some sites might have malware that advertise. So, but we did make money back, which was good and made me sleep a bit easier. So around the November to February mark, we decided just to disable Propeller Ads because they weren't offering a very good user experience to our site, and basically all the traffic slumped off anyway. Things went back to costing pretty much nothing to run on a daily basis. So we turned them off, and we kind of just forgot about it for a while, which is great, until phase 2 happened. And this section is called Cleaning Campus Ground and Scaling. So around the start of COVID, and so just before, I guess, just mid-April, we started to, or end of March, mid-April, we started to see traffic coming back to self-anime. We couldn't really work out why, but we decided, well, this is potentially going to be a problem. We should really start to look at how we can improve this project so it is able to remain up and potentially monetized. As you can see, costs obviously skyrocketed quite a bit over the course of this period. So let's talk about what happened during this period. So the first thing, and the extremely good news, is that we did get approved for Google Ads eventually. So we enabled Google Ads on our site. We were able to serve up ads and start making money back. And luckily, we are now making enough back that we can cover the costs of running the site, which is really all we wanted. And we're really, really happy about that. The other thing we solved was around privacy. So the images that we served up had to be stored because of the nature of us delivering them. Emailing raw images just wasn't going to work, so we were emailing out hashed links to users where they could view their image. However, the process of allowing the user to delete their images was fairly manual, so we implemented a really nice little opt-out process in the emails that everyone receives that allows them to permanently delete all their user data, which is good for everybody, means less work for us, manually deleting requests, and allows the users to delete their information very easily. Next was shareability. The process of embedding the links in emails was really kind of convoluted. You can't put JavaScript in emails, so things like Twitter and Facebook reshare buttons didn't really work very well. So what we did is we swapped out the images to basically use this HTML generated dynamically through lambdas that get sent out to the user. And then that is actually able to be reshared with the proper OG image tags that allow them to have previews on social media, which actually improved our reshareability quite a bit. And this is architecture version 2 for people who are interested. So basically what we have here is more or less the same sort of architecture, but we swapped everything out for Fargate. The reason we went with Fargate was actually because they released, in version 1.4.0, 1.5.0, one of those, they released 20 gigabyte minimums on the sizes of containers, which was great for us because our container was about 17 gig, and before they were 10 gig limits. So we were now able to use spot instances on Fargate, which was incredible because it was cheaper than running a Kubernetes cluster, less total cost of ownership was reduced significantly, and it now scales fully autonomously, which is awesome. We also added some observability. We used X-Ray for this. This allowed us to kind of pick up when there were problems with our site. In some cases, we had like dead endpoints and whatnot. This was super handy. It saved us a number of times. In fact, our website was down for an entire day and we didn't even realize it because one of the API endpoints was going to the wrong spot. So we had X-Ray and I went and checked X-Ray and it's like, yeah, your site doesn't work. And we're like, oh, well, that's a problem we should fix. So let's go through the closing thoughts. I recommend if you want to get into maybe working with ML on some personal projects is build some cool proof of concepts fast, make tons of mistakes, and just learn from everything you can. If you deal with users' data, take privacy really seriously. We did actually speak with a lawyer. We paid a lawyer to look at our basically look at our privacy policy and build it for us. And if you update your privacy policy, make sure you date it because it's really important for your own personal understanding of at what points you need to deal with people's data differently. I cannot stress this enough. You need to be careful. Monetization can be really difficult as well, especially for these single service sites. So don't plan that you can immediately start making money just because you're getting a lot of traffic. If you want to use Google Ads and ad platforms, you need to do your research and really understand what you need to put on your website in order to get approved. Things like search engine optimization are really, really important. And if you design your site around these, you'll get approved, no problems. Also, just leverage fully managed services where you can, because you don't want to be running EC2 instances up with these things on it, because you're going to have to check on those instances. If you can use services like Fargate, Lambda, DynamoDB, any service where you don't need to really worry too much about that service being up, it's mostly serverless, you're going to have a much, much better time. And that's kind of it for this talk. I want to wrap things up by just giving you some links to some of the resources for this site. So there we have the repo for the these cats do not exist, along with the URL for it, and Selfie to Anime. We have split repos, so myself, I host the code for all the backend and serverless systems, and then Rico, which is Silent Byte, hosts the front-end website, which is also open source. So if you want to take the code, fork it, play around with it, have some fun with it, build your own models, feel free to jump and grab the code from there. And you can talk to me on Twitter. There's my Twitter tag there, at Nathan Glover AUS. Ask me questions, anything. I'm happy to talk to you about this. So without further ado, I will wrap this up and we can have question time if there are any. Thank you guys.